Hi, my name is Vaibhav Parashari, and today in Electronics Lab 3, which is Digital Lab, I'm going to demonstrate experiment which is 4-bit up counter. So I'm going to conduct this experiment by using two methods. First, I'm using these chips, which is counter and CD4010, and another by using Arduino board. So this is my ID. Let us start. Okay, so in this digital experiment 3, our task is to configure the counter IC to count up from 4-bit 0000 to 1111. But first, I'm going to understand the pin configuration of this IC74LS163 and what pins I'm going to use to work this experiment. Okay, so here it is the IC LS163. For this experiment, I'm going to use this pin 2 as a load, and these output QA, QB, QC and QD. In the figure, I'm going to this load and QA, QB, QC, QD. Along with this IC, I'm also going to use this another IC which is CD40106. So the counter operations will be incremented on each clock pulse. The testing processes connect to this QA, QB, QC and QD of the output to these given inputs or these LEDs. As a result, these counter cycles through all 16 possible outcomes from 0 to 50. And the work of this CD4010 IC is to connect the VCC to the 5 volt of the ADLM and pin 7 to the ground. And it ensures the clean and stable clock signals for the counter and reduces the counts or the false triggering. Okay, so for the testing processes, I'm going to use this pin 2 of both of the ICs and the output of this QA, QB, QC and QD, as we are connecting 5 volt to the and I'm going to set this 1 Hz. Okay, so I'm going to repeat it sweep and the sample time is to 1 second or 10 nanosecond. Okay, I connect this channel A to the pin 1 of this hex IC, and now let us see the output of these LEDs. Alright, so I'm going to blink this LEDs for 0000 to 1111. Alright, so this seems nice. Let us check these output one by one to these least significant bit to the most significant bit, SQD to QA. And for the second pin, I am going to connect this to channel B of this ADLM and check in this pixel pulse of the major output. Okay, so I connect this to channel B and check this at Q4. And the output, let us see, 10 nanosecond. Okay, so it comes around 2 volt. Right, now Q3 or QC. Alright, so there is a change at this is slightly decreased, and there is a increment. Now Q2. Alright, so it is around 3.5 or 3.3 because there is also a and now most significant bit, which is Q1. Alright, so it is around 3.5. So I'm going to do this experiment using another method, which is by using the Arduino board. So pin 9 of this Arduino board, we will connect. I'm gonna connect this to this IC pin 2. So firstly, what I have to write a code of this Arduino Uno to work this pin 9 on this IC. So here I have write a code to activate this Arduino, and this pin 9 is often used for specific purposes, like for timer functionality, and basically we are going to generate frequencies or controlling the brightnesses of this LEDs. It allows output analog signals, which is useful for adjusting these LEDs and generating specific frequencies. So that's why I'm going to use this pin 9 of the Arduino and connect it to the counter pin 2. Okay, so I'm going to blink these LEDs for a while. And it is actually working fine. Now what I have done here, I'm going to connect this channel B of this ADLM kit to these output LEDs to check the voltage square function of this channel B in the Pixel Pulse app. So let us check that. Okay, so I adjust this 5 volt and frequency is to 1 Hz. Let us check the output at B. Alright, so I'm going to check this one by one to this least significant to most significant bit. So this is slightly lesser than Q4 is slightly lesser than. I'm going to connect this Q4. Okay, so just refresh it for a while. It is increasing. Now Q2. Okay, alright, so it is around 2 volt and this is 0. This tends to 0. Alright, so now it's time to